Okay, so I think enough people has joined up and we can
Yeah.
now slowly begin our presentation. So the topic today is a complete guide to 3D surveys updated coordinate systems. So our users, you have probably already noticed that in version 3.0, we've updated how coordinate systems work. And now in this webinar, we will tell you about all the small tricks and tips how to use those coordinate systems and what all the settings do. So it does appear that we have small technical issues today. My colleagues have just told me that you already see the next slide. We don't have many slides, so I think this will not be a huge problem for our presentation.
Yeah, not a huge problem, I think. Not too many spoilers. Okay, I think that was good introduction. Maybe to break the ice a bit more, we can jump into a few questions, do a quick poll. Are we ready with?
Yeah, we are ready. You can go ahead and launch the poll.
Okay, so we'd like to ask you first, how familiar are you with the coordinate systems? So how would you rate your understanding of coordinate systems? This is more general question. So the options range from 1 to 5. 1 being not at all, so you don't really know what coordinate systems are, and 5 being a completely understanding coordinate systems. So maybe if you are a professor or a really but 2, 3, and 4 are also options. So I think votes are coming along nicely.
Yeah, by now 75% of people have already voted.
Okay,
77.
let's just a few more percent, and then we are closing the poll. Okay, I see some of the late attendees are joining us still. So I'll just repeat this question for you who've just joined. How would you rate your understanding of coordinate systems from 1 to 5? 1 being not at all, 3 fairly okay, and 5 completely. So cast your votes now. In a few seconds, we're closing the question. 3, 2, 1, close. Okay, I can share these results with you to see what does our attendance rate look like. So most of you have good understanding of coordinate systems. A lot of you would say completely, 13%, and fairly good is a very nice amount too, 30% of you, and some of you are more on the beginner side. So I think this webinar will cover everyone. After this, you should be ready and have no problems to work with coordinate systems in 3D survey. So now let's go to our next poll. Let me just find the second question. This is a classic. Of course, we have to ask you this one. Are you already a 3D survey user? Yes, not yet. And we've added the third option this time. So for those in between, I'm thinking about buying the software. So if you're already browsing our website and looking for your favorite option to get on board with 3D Survey, maybe you can choose the third one. We have a few options. There's perpetual license, there's subscription-based model. They work the same once you've purchased the software. Functionalities are the same. It's just depends on your financial preferences. Okay, now we've got 80% of votes already. I think we can close this one. And here are the results. 83 of you are already users of 3D Survey. Very nice to hear. But we welcome also those who are not yet users and those who are thinking about it especially. So thank you for these votes. And I think we're already warmed up enough now, so we can go on to more serious stuff, which Vid will explain to you now. Vid, it's all
Okay.
yours.
We can close the poll now. So
Yeah.
let's do that, and I will switch again to sharing my screen like that.
Perfect.
And we continue to the second slide. So the presentation timeline today will consist of 5 topics. So first, we will look at how to use the new coordinate system, and most importantly, I will talk about coordinate system presets, why they are and why we chose to use them. Second, to make everything super clear, we will talk about differences of geographic versus projected coordinate systems and how that applies to 3D survey. Also, we will explain in detail the difference between projected and input coordinate systems, then what are grid files and who needs to use them. And finally, we will end by talking about how to use custom PRJ files to define your own coordinate system or how to change the existing one. Right, let's begin with our first topic. So that is using the new coordinate system presets. So when you open 3D Survey, let's go like that. And typically
Perfect.
we start by loading the images. I'll go here, image, load images. I will select a few images from this folder. So this is the window that we will get here. Typically here by default, the user interface will be set to this one. So when you first start 3D Survey, the default coordinate system preset which will be selected will be WGS84 UTM automatic zone detection. So this is the coordinate system that we select for you by default. This is the one that is defined for the whole world. That's why it's called the WGS, World Geodetic System. It automatically selects the appropriate UTM group and it automatically applies the EGM 2018 elevation model. But most of you will need to select the coordinate system which is relevant to your specific country. To do that, we've made it so that you should set the coordinate system preset up here. So the first thing, and you should select your coordinate system by either entering your state name or entering your country name. So if you come from United States, where each state has its own coordinate system, you should write the state name. On the other hand, if you come from a smaller country, you should just start entering your country name. So let's see how that works. So the pictures we are looking here, they are from New Mexico. So we will start writing New Mexico. And now I have here 3 options. So this one was recorded in the western part of New Mexico, so I will select this one. So selecting this preset, it sets the appropriate horizontal coordinate system, which in this case is NAD, so North American Datum 83, version 2011, New Mexico West, and it also sets the appropriate unit. In this case, this is feet US. And it also selects the appropriate vertical component of the coordinate system, which is the NAVD88, which also has feet per unit. So if you would want, for example, to change this now, you can also change it here, and you can select here. If we go and check which vertical coordinate systems we have, you could also set for the coordinate system to have depth, and there are also different units. So this one with no units specified, if we selected that one, the elevations would be in meters, so we don't want that. Secondly, we have two options. So you have to be careful about this. So you can have elevations in US survey feet, or you can have it in international foot. So here, this is a bit specific. So each country has its own setting. So in order to make that easier for people not to make mistakes here and by mistake select incorrect coordinate system, we decided just here to add under coordinate system presets for each country where we have users from. So we have for each of these countries, we checked which is the correct coordinate system and we have selected it. And you can see here some countries, they have multiple coordinate systems like Canada, which is huge. They have a lot of zones, so they are all specified there. Some European countries have more, some have less. There are some countries where you only have one coordinate system, which I think is the best. But in order to get it, you simply start writing your country name here. So for example, you select Korea, and then you have Korea, and you select the new version coordinate system or the old one. And here you have also combinations with different geoid models. So for example, if we check Turkey, on the other hand, in Turkey, you have different coordinate system zones, but you also have an option to use different coordinates, different geoid models. So you can select combination with the geoid model from 2022, or this one, the older one from 2003. So basically, at this point, you just need to select your country name and then select the appropriate combination of horizontal and vertical coordinate system from the list here. If you select that one, it will also then apply the correct geoid model in order to convert the ellipsoidal elevations, which your telemetry data will typically have, into orthometric elevations for your final project results. And this is the most important part about the new coordinate systems. So I will repeat that one more time. To select the appropriate one, start typing your country or state name in here under coordinate system preset. Right. Now for the second topic. So we have different kinds of coordinate systems. But for our presentation, I will try to make it as simple as possible. So I will not go into all details, but we will distinguish between geographic and projected coordinate systems. So geographic coordinate systems are used to describe the position on the whole Earth's surface. So with geographic coordinate systems, the position is typically described by two angles and one elevation. So the position on Earth is described by latitude and longitude information. Typically, this is in degrees. And then we also have altitude. So this will either be ellipsoidal elevation, or it can also be distance from the mid-sphere. But most of the time, in survey, we use ellipsoidal elevation. And this one is I think it's always in meters. So there are a few different geographic coordinate systems. There is the WGS 84 one, there is ETRS in Europe, there is Canadian one in Canada, North American one for North America. And this is what typically the drone telemetry will be in. So typically when you fly your drone and you get your positions, you will get your position in geographic coordinate system. Which one we will check later. So those coordinates we typically then transform into projected coordinate system. The projected coordinate system are grid coordinates in which we typically work. So grid coordinates will then have for coordinates easting, northing, and elevation, and the unit will either be a meter, feet, or US survey foot. So, and here we have a sketch how the coordinate systems, how they look. So if I now go back to 3Dsurvey, to our coordinate system here. So here we have this you see that here next to the coordinate systems, we have here these kinds of icons. So I made this introduction about the difference between geographic and horizontal coordinate system, because here in 3Dsurvey, with this icon here, if we see this globe, that means that we are talking about geographic coordinate system. So this one has for units angles like latitude and longitude. And for our project coordinate system, in this case, we have here projected coordinate system, and because of that, we show it with this grid. And for the vertical coordinate system, we show it with this icon. It just shows us height from certain reference plane or surface. Right. So now I would like to show you something here on a website. So it turns out that even if you have geographic coordinate systems, so here I have example for US. If I try to convert, I have here latitude and longitude for some point in central US. So we have a coordinate of 100 degrees west and 40 degrees north. If I convert that point from NAD 83 coordinate system into the new one, NAD 83 2011, these two coordinates are not the same, but they are different by here about 4/1000ths of a second. If we convert that back into meters or feet, this comes to about 13 centimeter error, or that is about 5 inches. So it's a small difference, but it's already something that we need to be mindful about. So even different geographic coordinate systems, when we convert between them, it can happen that the coordinates will be slightly different. This can happen for two reasons. One could be, which would be typical reason in Europe, that the coordinate system is old, and when coordinate system was defined, we did not yet have GPS, so the coordinate system definition might not be 100% accurate, but it might have about 1 meter error, whereas is the case here in US, where this I think comes from the continental drift. And so that means that coordinates measured in maybe sometime in beginning of 2000, if you measure them again today, the continent has in the meantime drifted by 13 centimeters. Right, so why do I make this description? Because now we will be talking about the difference between input and project coordinate system. So let's come back here and let's check this. So when I select here, for example, New Mexico, that does not only set this part down here, the horizontal coordinate system of a project and vertical coordinate system of a project, it also sets the input coordinate system. So it sets the input to geographic coordinate system version 2011 and ellipsoidal elevations here. So why is that important? So let's check this folder with the images here. Let me go to my folder where these images are at. So typically the photos which we record with the drones, or even if we record them with some external device, they will have some positioning information. That information can be in two places. Usually we can just check it if we go here to properties and to details and we scroll down. Here we have this GPS section. So we get latitude, longitude, and altitude information. But we do not get information in which geographic coordinates system these coordinates are in. But most of the time we can tell, because if you are in US and you connect your drone to Ntrip, to get accurate position, in that case, you will get geographic coordinates in this coordinate system. And if you set your coordinate system through preset, this one will be filled out automatically for you. For example, if I change this one now to, let's say, Germany, this part up here, it changes to ETRS 89. So that means European Terrestrial System 89 with ellipsoidal elevations, because that's what you would get if you connected your drone to N-trip in Germany and you would do a flight.
So basically, with what you're saying here, we don't need to worry about the input coordinate system. The preset sets it for you.
Yeah, because of that, by default, the input coordinate system is hidden like that. And we try to guide you to start with the first field here. So just by starting your country name.
Yes. I think
Okay.
that's quite clear. I would just like to make a note, if anybody has a specific questions that we may not cover, feel free to write them in the box and we'll attend to them at the end of WIT's program, so at the end of the webinar.
Yeah, exactly.
Okay, let's continue.
Okay, so that was the difference between input and project coordinate system. Input coordinate system, that means the coordinate system that drone telemetry is in. Those coordinates are written in the images themselves. They can be part of EXIF, or they can be also stored deeper in the images, in the part of XMP section of JPEG. But I want to keep this webinar simple, so I won't go into that and how you can check those coordinates which are written in there. If we find them, we take the coordinates which are more accurate. Okay, let's continue. And now for the sixth topic. So now we will also be talking about grid files and who needs to use them and what grid files are. So a grid file is a file which we apply to transformation to make the transformation more accurate. And this is basically what a grid, this is a representation of a grid file. Typical grid file will just contain numbers. So the numbers it would contain. So here it could be a value of 0, 0. That means add zeros, add no corrections if you are in this corner here. But if you are in this corner down here, it means that, so if you are a bit more to south and a bit more to west, this would suggest that easting coordinate should be a little bit decreased. So why grid files are important? As I mentioned earlier, in Europe, about 50% of countries, they use coordinate systems which were defined at the beginning of the 20th century. So back then, we did not yet have any GPS. We were only able to measure angles and distances in order to make a network of points which then define coordinate systems. Because we were only measuring angles and distance, the coordinate system definition was not uniform. It did not have uniform accuracy. So point measured here in the north, it might be that the triangle net, those state reference points, that they all have coordinates which have easting value low by, for example, 5 meters. And down here on this side, in the south east, maybe here easting was 3 meters too big and northing 3 meters too small. So the people who come from countries who have this kind of coordinate system, they typically know. So here, for example, one example we will use is, for example, from Austria. If we go here to telemetry and try to import it, and I select as a coordinate system Austria, let's say this one was recorded in the eastern part. In that case, in order to accurately convert the GPS ETRS89 coordinates into the old MGI Austria Gauss-Krieger coordinates, we need to apply two things. We need to apply first corrections from this GIS grid from 2011, where those distortions are defined. And we also, and the second one here listed is the geoid model, which will be applied in order to convert the ellipsoidal elevations into the new 2000 version of the elevation model. So down here, we then also have here an option. So here you can actually select with geoid model to select. By default, everyone should just leave this open. Austria is actually the only example of a country where we need to fill these coordinates up, and we can check here. We can select to have this GIS grid applied. And the second thing is here we can choose between the two geoid models in order to convert the elevations into this one. For this one, it's the only one because of Austria. There is this geoid file filter, but if you are from any other country, you can just simply ignore this field down here. And everything will be, and for everyone, the default settings are part of the preset up here. So everything is set up automatically.
Reed, can I have a quick question here?
Yeah.
Maybe if we saw the list of horizontal coordinate system a bit closer, we noticed there are some horizontal coordinate systems that have 3D in them. So are these 3D horizontal coordinate system? How does that work?
Oh yeah. So with 3D Survey 3.0, we decided to support the whole world, and there are two kinds of coordinate system. By default, most countries we have separate 2D coordinate system and the 3D and the vertical coordinate system. But the coordinate system can also be 3D. That means that both horizontal and vertical part of the coordinate system are defined in one. And in that case, we can just have here one 3D coordinate system, and you don't need to set a separate vertical coordinate system. So I think we can find them like, I think we can do it like that, 3D.
That's 3-3.
Yeah. And then you would get a list of them. So even if we go down here and select some of the coordinate system, some from the list will be 3D coordinate systems, and they have both information. Like for example, we have here for the Finland. So both horizontal and vertical are defined in here, and in that case, you don't need to select the vertical component down here. So that's it. The same goes for the projected, for the geographic coordinate system. So geographic coordinate system can also be 3D, and in that case, you won't have the ellipsoidal elevations down here, but it will be part of the definition of this CPSG code. So yeah, the coordinate system, when you get down into the guts of it, it can be a bit confusing. There are many different things to keep in mind about them. But the final thing to say, I still think the best way to set them is just to start by typing your country name here.
Okay.
But still, sometimes it might happen that the coordinate system you are trying to use, you will not find it. So for example, typical situation is also in US. So the coordinate system we take from the EPSG database. So it's the Petroleum and Gas Consortium. They have compiled the best known database of coordinate systems. But sometimes there might be a country, there might be a county usually or a state where they use a coordinate system, And for example, the one that you will find, it will not be perfect for you. So it might happen that you want coordinate system with US survey fit, but the only one you find has units in meters. So I don't know, let's try. For this, I'll just write, let's try to select one here, Hawaii. Okay. So for this demonstration, so I think today in Hawaii, typically, so let's say that you are in Hawaii zone 2, but you see here that you get coordinate system in feet only for zone 3. What you can do, you can select this one, select the vertical. I'll just leave it the vertical component for the purpose of this demonstration, only select the elevations. And here, let's set that one. Let's set again New Mexico. That will set this one. Now down here we will change this one back to Hawaii. And here we will select, for example, zone 2. Now this one is changing to custom coordinate system. That's important. So now if you import these images, you see that the units here are in meters because the coordinate system that was used had as a unit set meters. So now we are going to our final part of the presentation when we are talking about using custom PRJ files. So we are here, like that. So let's say you don't want to use meters. You can come here, and the coordinate system information is written here. You will notice that we have now here this save icon. What I can do, I can use save.
Yeah, okay, this screen, yes. We were not able to see the previous window. So can you just show us where to click again?
Yeah, so down here.
Yeah,
so
down in the right corner.
Down here where we have the coordinate system name, Hawaii zone. So here we have what is currently set. We have this small save icon here, export project coordinate system. And we can then save all the information regarding this project coordinate system into a PRJ file. Let's try to do that. So here actually typically you have different options because these files can be different. The best one to use is actually the first one. Press select. And then the information about the project coordinate system gets saved in here. We can open that one up. And then here we have all the information about coordinate systems. So here in this one, what you can do, you can change units of coordinate system, and you can also change the orders of the coordinate system. So here, by default, unit is defined to meters, and then the axis order, the first axis is called easting, short east, then northing, short north, and here is also the authority. So if you wanted to swap out the unit to meters, you would just change these values here. So you change this one to US survey foot or feet, and then change this one to whatever the scale between the meters and feet is. If you want to check how that looks, you can just go to different one here. So here we will select New Mexico. One thing I forgot to mention in the beginning of presentation. So when we make the import, if additional files are needed, the software will download them automatically. So just press continue here. That will be automatically downloaded and stored for future use. Now press close here. And if I now save this PRJ file into an external file, again, we will use this convention. The simplest way is then just to select this coordinate system and just take this part here, Control C, and copy it into Hawaii, like that, I think. If you do it like that, you have to be super careful about these brackets and make sure that the brackets are correct. But now I have just saved the coordinate system. I have changed the units. We are leaving the axes how they are. And if I now save this one and right here, so we now have US survey fit. So fit US PRJ like that. So for my project here, I can then go project, new project, no.
It's important to start a new project because project is defined by its coordinate system, right? So you cannot change it later on.
So the file, we have saved it. I'll just take this folder. Let's save it one more time. Why is it missing here?
Maybe use the desktop.
Okay, back to 3D survey. We are actually in load images. Project images, load images. So here I just want to load some images. I'll just go here to my project folder and go to somewhere where we have a lot of nice projects. Down here, these are some images from US, though they are from New Mexico. And then we'll come here, and instead of a preset, we will use this one, import PRJ WKT. And now here we can select Hawaii Zone 2. This one is the regular one. And this one has fit US. Select that one. You would import. And now instead of meters here, we have here US survey fit.
Okay, that's great. That looked quite advanced. So normal 3D survey user would probably never need to use this, right?
Yeah, and actually, if you need to do this, instead of trying to do this yourself, I recommend you just send us an email and let's do it together. Because typically, when I try to edit something in here, if you make a mistake with one of these brackets, the file will not work and you will just get an error saying the file is incorrect, and it will not even tell you where the mistake is because we don't know where the mistake is.
Okay.
So in that case, I recommend you just write us an email. Also, if your preset is not in the preset list, again, just write us an email and we will prepare a PRJ file for you. And in the future version of 3D Survey, we will add the preset so that you will only get to enter again your country name and then select the appropriate coordinate system preset from the list. So
you have actually seen now how this is created.
Yeah. And what you should take from this webinar, the best solution should always be for you to just go here webinar. Let's move this window away. Data telemetry import. If your country name is not on the list here, just send us an email and we will add your coordinate system down here. We will create a PRJ file for you to share with you so that you can use it.
Great. Once again, if you have any more questions, some of you have already set them, and we will go to them well right now, or do we have anything else before that?
So this was a short presentation. So the goal was to make it 30 minutes, but we came down to 40 or 45. Now we have some time to also check the questions from our users. Yeah.
Or we could do the last question from our side first.
Oh, yeah, of course.
So it's a really simple one, just to evaluate our effort on coordinate systems. I'll launch it now. So how complex do you find coordinate systems settings in 3D Survey? So is it very complex, simple, or something in between? As you have seen, you have a lot of options. We wanted to cover every place on Earth so you can work in your local coordinate system, that is to achieve the greatest possible accuracy. We have tried to add the presets to make things as easiest as possible. So let us know with this answers here. I'll give you a few more seconds, and then we will check your questions. As I said, a few of them have already wrote them, and you still have time to enter your own. Okay, so let's see, more than half of you have voted. Now let's see the results. So that's quite a good result. Only 9% of you find it very complex. Most of you find it simple, that's 61%, and in between 30%. That's fair. Okay, are we ready for the actual questions from our users?
Yes. Okay, we actually have some pretty good questions. So let's just go with the questions in the same order as they were arriving. So
Agreed.
the first one is a typical one. Good morning. Is it possible to receive the recording of this webinar? Yes. Everyone who attended the webinar and also everyone who just registered for the webinar will get a recording. So by tomorrow or something like that, you will get an email with the recording of this webinar.
Yes.
Now we have two similar questions. I think they are coming from South Africa. The first one is, hi, very new to the entire surveying space. In South Africa, we have different LO coordinates, LO19, LO21, for example. Where do I determine which LO level I need to use? And the second question is actually very similar to that one. Good day, kindly share input coordinate system for South Africa LO29. Okay, let's come first to 3D survey. Maybe let's go to this 3D survey window. If I write here for preset South Africa, we see that we have here a number of different coordinate systems. Let's check out this one first, LO19. So here it tells us that we are working in Hartes PEC 94 LO19. The important thing we can use is we get this EPSG number. So how I like to check what the coordinate system actually is, I just take this number, 2048. Then I go online to one of the coordinate system databases. So the default coordinate system database is this one. It's called epsg.org. But I find this one a bit hard to use. You can go here into text and search by this text. and it works most of the time. But actually, there is also a better solution. There is an official version of database. It's called EPSG.io. I just write it down to see where you get EPSG.io. So we are here. And here we can then search for more information about our coordinate system. So you can write in here the country name, or I think we can put in here just the number. So this is the EPSG code. It's Hartes Besthög 94. I click on this one. I scroll down, and down here I have information about this coordinate system. So usually, well, typically, when we want to check which is the appropriate coordinate system to use, we have to check what the central meridian for our coordinate system is. So this one has a central meridian of 19 degrees east, I would say. So 19 degrees east, that means that is for locations down here in South Africa. Let's move these questions away. You don't see them, but they are in my way. So the version 19, that is for this area here, where the coordinates are closer to 19 degrees east than they are to the next one. And the next one, in our case, I think it's 21. So we go here. The next one here, yeah, you have 19, 21, 23. You check your longitude, and if your longitude is more similar to 21 than it is to 19, then you will use this one. And the same goes for Canada, for Finland, for all the big countries. Also, sometimes in the coordinate system description, there will also be this additional information down here. It can be there or it cannot be. Change this. It might have South Africa onshore between 18 degrees east and 20 degrees east. So here in the description, you can also get this information. And you get bounding box with coordinates where this coordinate system is applied. So excellent question, Rudy. Thank you.
Okay. We have a few more.
Okay. There was a question we received during the presentation. It says you did not mention 3D horizontal coordinate systems, but Mattia kindly reminded me to mention that there exist also 3D coordinate systems. So I see this one is more. We had answer done. And then again, a question from South Africa. On the grid geoid, do I click the SAGeoid? No, you don't need to click on it. So when you load in, when you select this, if I had images from South Africa to which geoid would be applied, you can leave this for you, this grid geoid file filter is irrelevant. Just select this one, press import, and everything will be set up automatically. So you see in your case, the geographic coordinates, the input geographic coordinate system is set to, again, to your state coordinate system, ellipsoidal elevation, and then your results will be in this grid and in this vertical coordinate system. And in order to get this vertical coordinate system, the grid file will be, for you, it will be automatically applied. For me, it is not, because these images are from Slovenia and the grid is not valid up here. So because of that, it cannot apply it. Interesting question from Andres Aponte. So, good morning. How do I export the GCP data from the project? Well, you can't. There is one trick you can use to get it. I use it all the time. So let's say that you have a let me go here. Cancel this, close this, and go project, open.
I mean, there's no command export GCPs, but you
There
can
is no
do
command
virtually the
export.
same.
There is a way to achieve that. We'll just open this project. So here we have some coordinates that were loaded into project. Let's say that we lost that file, and now we want to get these versions into a file without having to type all of this. What you can do, you can go here to project, generate report, generate project report. We will call this one the file example export GCP. So what I'm showing you is a workaround. This will now create a document with information about that project. And inside this document, there will be a Word file. And now, for example, open with LibreOffice, for example. Well, LibreOffice, where are you? Discard all. Yes. Cancel. I opened it in LibreOffice because LibreOffice works best for exporting this information. If you scroll down, you will see you have here the list of coordinates and the list of ground control point errors. So what I do then, the best way to export it, first step, go copy, then I open LibreOffice Calc, paste it in here, and then from here I take it and I put it into a TXT file.
Yeah.
If you do it like that, it works best, and you automatically get this nice list of points with nice separators.
And if you haven't lost this original file, you can just load it as CAD and then save it through save CAD command and then choose the file type you wish. But yeah, if you need to do that.
Yeah, so a bit specific question, but a good one as well. Okay, another question. If I do click that, the coordinate system preset changes.
That's connected to the previous one that you've answered about the SAG GUID.
Okay. So let's explain this one in a little bit more. I wonder if I have any images from South Africa, but I'm not sure if I would be able to find images from South Africa now very quickly. I did have some, but you know, I have so many of these projects. Probably received it a few years ago.
I'm guessing the short answer is just don't click it.
Yeah. Let's go here. I will use Slovenia for my example. So select this one to Slovenia, where we are from. We only have one coordinate system. So if you change anything here, the coordinate system now it's no longer preset, it is now custom. So that means you change something from the preset, then here it will say custom. Again, our recommendation, just write your country name here, and then just leave it as it is and press import. So in case of South Africa, just select South Africa. Let's say that you are close to meridian 29. Select that one. Don't click here, don't click here, and don't click here. Just press import, and you will get the appropriate coordinates. Okay. Let's continue with the next question, and this one is also a good one. Can I have your email, please? It says. It comes from George. Of course, gladly. So for further questions, just send us an email at support@3 3Dsurvey.si.
I also wrote it there.
Here, and we usually respond in a few hours, but most of the time in one day you will get a response. Even if we go on vacation, someone is always checking this email so that we can give you support for the difficult questions to get you from your input data to useful and actionable results.
And 90% of time, Reed is the one who's reading this email, so it's not just anyone. It's with the expert. I think we have just 2 more questions. So yeah, we'll do this too.
The next one is a hard one. Hi, I have a problem with coordinate system in Macedonia. We have state to the EPSG 6316, but with RTK image I have around 44 meters difference in height. How can I fix that? We have grid transformation and we must put for every grid 10 by 10 kilometers. So I'm not sure I understand this correctly. I think the situation in Macedonia is you have you do specific transformation for each depending on when you are, so you don't use the grid file to do the transformation, but you have different, let's zoom this one out a little bit. So the transformation from the ETRS 89 Geographic geodetic datum to old Gauss-Krieger datum, you have different one based on the region you come from. In that case, what you need is, so let's go here to this one, Hawaii. There should be here, so you have an option in the PRJ file to define the transformation parameters. These are called 2WGS84. Maybe it will be best if we just go to EPSG database and check this one, 6316. Fast way to do that, you can just write it here. Balkan zone 4. So yeah, down here there are these 2 WGS84 transformations. So you need to get the transformation parameters from this coordinate system, MGI 1901, to the WGS 84. So this means 682 meters shift in easting, minus 203 meters shift in northing, 48 in Z, and it has no rotation and no scale change. So typically, I think your numbers that you will want to use will have a bit more decimal spaces in here, and with those you will get more accurate transformations. The problem is the transformation that you need, it needs to be to WGS. That means from this one to WGS, not the other way around. So that's the problematic part where you have to get those parameters. You would put this in a file, save it, and import it as a PRJ, and then you can use it. Okay.
Okay, then we just have one more question.
What if a project is between 2 LO coordinates? It overlaps too. I think the answer here is you have to use. So usually, I'm not an expert about South African coordinate system, but usually I think it's like that. So based on the state you come from, so each state will have a special definition. In cadastral information will say, for this state here, we will use that LO from here to there. South Africa is a very big country. 2 degrees, that's like, I'm not sure, it might come to about 500 kilometers. I think it can happen very rarely that you will get here images where one part of images will be closer to this one and the other one will be closer to the
It's quite huge, so
yeah,
maybe you already have some other problems.
I think usually in the cadastre you have, like, for example, you would have Victoria West County. Most of Victoria West County is closer to 23 in this example, so for the whole of Victoria West you will be using the LO23. So
Okay.
actually, I might be guessing a little bit here, but if you want to have a perfect explanation how to use, we do have a partner in South Africa. His name is William. You can find his information if you go to our website, 3D Survey. And so, Mattia, help me, where do I find our partners? I think it's under resources.
Or I think if you just scroll all the way down,
Locate a partner.
locate a partner, exactly.
And down here you can find for South Africa, SSS. It's down here, surveyors on a mission. And you get a link directly to their website. And they will be experts on South African coordinate system, and I'm sure they will be able to answer in detail, more detailed
That's
questions.
Great. And these were all the questions. So thank you everybody for setting them. And thanks everybody for coming.
Yeah.
But before we finish off, I have a small announcement also to make. Because these new coordinate systems were presented in the versions 3.3 and higher, you may be behind with the updates. And if you are not on track, our sales department has prepared a nice discount options for you to get back on track by a smaller price. And that's, if you check, I will paste this link in the chat where you can visit our landing page and get on track for less. This is still valid till a few weeks, and yeah, because the reason why this action now is applied is because if you haven't upgraded for more than 2 years, it gets a bit more expensive. But we don't want to lose you on the older versions. You can now upgrade for a reduced price and be on the best 3Survey version. So yeah, that's that. And maybe we can give another hint, since we're already giving stuff away. It really pays to update right now because we are working very hard on the new version that's coming out soon, and it will be a really good one. So stay tuned for that, and we will see you on the next webinar. Yeah.
Thanks for joining us, and looking
Thanks.
forward to seeing you again.
Yeah. Enjoy the rest of your day. Bye-bye.
Bye-bye.